Hi there, in this video we're going to learn different ways of using analog signals. First, we'll have a short introduction to see what's the main difference between digital and analog inputs or outputs. Then I'll show you how these potentiometers can be used. After that, I'll explain how these analog inputs and outputs can be used. Finally, I'll explain how extension modules can be used by these two instructions, to and from. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the plcgoods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's see the main difference between digital and analog devices in industries. As you know, equipment like push buttons and signal lamps, which have only two states, can be connected to digital inputs and digital outputs. But a variety of equipment, like level transmitters, flow meters, electrical valves, and motors work with a range of voltage, current, or other signal types. So, PLC will need more than one bit to store their state. In this video, we'll learn how this type of equipment can be connected to my PLC. First, let's start with these two potentiometers, because they can be used as two analog devices. If you remember, this user manual, which was used during the first video, describes my Delta PLC hardware. As you see, my PLC has two potentiometers with these names, VR0 and VR1. Now, let's search them on the help window, to learn how they can be used. As you see, there are 1-bit memory, and 1 data register for each potentiometer. For example, when M1178 is on, the first potentiometer will store a number between 0 and 255, in D1178. Now, let's write a simple program to test the first potentiometer. Alright, based on my program, the first digital input can enable or disable the first potentiometer. Also, if the potentiometer value is greater than 125, PLC will turn on the first digital output. Now, let's download and test the program. Okay, let me use the first digital input, to enable the first potentiometer. Now, I can use the first potentiometer to change the stored number in D1178. And if its value is greater than 125, the first LED will be on. Note that, if I disable the potentiometer, I won't able to change the stored value in D1178. As you see, I cannot turn off the first LED, because the potentiometer is disabled. So, I need to enable the potentiometer, to turn off the LED. Well, these potentiometers showed us a simple example of using analog signals. Another way is to use analog inputs and outputs, which are provided on my PLC. Let's go to my PLC user manual again. Well, this table displays my analog inputs and outputs specifications. My PLC only supports voltage and current signals within these ranges. Note that, like two previous potentiometers, each analog input or output has a certain data register. So, the most important point related to analog signals is the relationship between the voltage or current value and its corresponding value on the PLC memory. For example, PLC can receive a current signal from 4 to 20 mA and convert it to a number from 0 to 2000, or PLC must send a number between -2000 and 2000 to its analog outputs, to create a voltage between -10 and 10 volt. Another important point related to analog inputs and outputs is their wiring diagram. This diagram displays analog inputs wiring. In this video, I will use this wiring diagram to create a voltage signal at the first analog output. Now, let's go to the help window to find other information related to analog inputs/outputs. Alright, this information has been given for these types of Delta PLCs. The first table displays the supported analog input signals and their corresponding values on the PLC memory. Similarly, the second table displays analog output signals and their corresponding digital values. The third table describes special data registers related to analog inputs/outputs. Based on the table, my PLC uses these four addresses to store appeared voltage or current at its four analog inputs. This one can be used to enable or disable each analog input. By default, all of them are enabled. Also, my PLC uses these two addresses to create a voltage or current at its two analog outputs. Another important data register is D115. We can use it to select the signal type for each analog input or output. By default, the voltage signal type is selected. Now, let me use default settings, and use this data register to create a voltage at the first analog output. I must send a number to D1116. Let me modify the previous program. Now, I'm going to use the MOV instruction to send the stored number in D1178 by the first potentiometer to D1116 to generate a voltage at the first analog output. Now, let me add a special bit memory, M1000, to the second network. It does not have any special effect on my program. It will be on automatically when the PLC goes to run mode. Now, let's download and test the program. Well, first let me run my PLC, and then, based on the first network, enable the first potentiometer. Note that, I've used this multimeter to measure the voltage of the first analog output. Let me use the first potentiometer to change the stored number in D1178. Based on the second network, this value will move to D1116, and PLC generates a voltage at its first analog output. As you see, the voltage is between 0 and 1.3 volt. Note that, to generate a voltage between -10 to 10 volts, a number from -2000 to 2000 must send to D1116. But the generated number by the potentiometer is between 0 and 255. So, I need to use math instructions to change its scale. Let me use this formula to change the stored number by the first potentiometer to a number between -2000 and 2080. Well, based on the formula, I must write the number 16, not 8. Now, let me download the program to test my first analog output. Now, let me test my program. As you can see, at this time, I can use the first potentiometer to generate a voltage between -10 and 10 volt. Alright, until now, I've explained how these two potentiometers and also these analog inputs and outputs can be used. As you see, all of them are provided on my PLC. But what about when we need more inputs or outputs? At this time, we must use extension modules besides the CPU, like this figure. But what are the new input or output addresses? Let's go to the help window again. Okay. For these PLC types, here are an example with two tables. The first table is related to the extension modules which are installed on the left side of the CPU, and the second table displays addresses of extension modules, which are installed on the right side. These tables and their description can help you to use extension modules, but let me tell you an easier way. Click on this icon, Auxiliary Design of Extension Modules. In this window, first, a number must be selected. 0 means that what is the first extension module, which is connected to CPU, 1 refers to the next module, and so on. Suppose the first module, next to the PLC, is DVP04AD. That's an analog input module. Now, let's click on Setup. As you see, there are several options on the left side. First, let's go to the input mode setting. Now, in the middle of the setup window, we have two options, read and write. If the extension module is already programmed, and we just want to read the mode of that analog module, we must use the read register section. But before that, we must use the write register section to program the extension module. First, we determine at what condition our desired settings should be written. Let me use M1000. If you remember, it is a special memory. It will be on when the PLC goes to run mode. So, my desired settings will be written continuously in the PLC in running state. Now, the input signal type can be selected for each analog input of the selected extension module. Finally, I click on this button, Add to List, to create appropriate instructions on the right side. Note that these instructions will be added to my program. Well, the selected extension module, DVP04AD, has 4 analog inputs, and at the first step, we've determined the signal type for each analog input. Now, I must determine which information I need. For example, suppose I need the present value at the second analog input. As you see, only the read register can be activated. Then, I must determine a condition that determines when PLC must read the present value. After that, an address must be determined, like D25, to store the analog signal value at the selected analog input. Again, let me click here to create appropriate instructions on the right side. As you see, 2 instructions were added here, to and from. Now let me click on OK. As you see, 2 networks have been added to my program. The first one uses to instruction, to program the selected extension module and determine the signal type of each analog input. The second network uses from instruction, to read desired signal value and store it in D25. Similarly, we can program and use analog output modules. At this time, suppose the first module next to CPU is DVP04DA. That's an extension module with 4 analog output channels. Like the analog input module, first, the signal types of the extension module must be determined. Now, let me select channel 1 output value to use the first analog output. Let me determine the condition, and now, I can use a constant number to create a specific voltage or current at the analog output, or use a memory address like D1178. Note that, on the left side, there are more options like adjusted offset, gain, error status, and etc. related to each extension module, that can be used similarly. Now let me click on OK. As you see, again, 2 networks have been added. The first one determines the settings related to the extension module, and the next one sends the stored value in D1178, to the selected analog output. Note that, the used instructions, from, and to, are accessible under the serial I/O instructions list. You can use them directly, or search them in the help window to read their description. I hope you have learned how analog signals can be used in ISPSoft software. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.